This is about SNMP and its versions. Okay, so next we'll go further with another application layer protocol, that is DNS. Okay, so DNS stands for
Domain
domain
name.
name system. So why it's required? Okay, so suppose in normal cases, in general scenarios, okay, you are trying to access any web browser, right? From browser you are trying to access any website. Okay, google.com, whatever the website you are trying to access by using a browser. Okay, so you are trying to access with some name only, na, google.com or some name, right? So
Yeah,
so here it's not I mean, on the back end what happened, it's a destination, right? Source is your IP address, destination is google.com. Okay, so even for the destination it should be some IP address, right? So this google.com will be internally converted to some IP address. Okay, so we can say so like it's a DNS is nothing but it's a kind of phone book. Okay, so in your phone book you'll be having some hundreds of contacts. Okay, so is it possible for you to remember all these 100 numbers?
no.
No, right? So that's why what we are doing, we are keeping some name to each and every phone
Contact.
number, right? So
Yeah,
by using this phone number you are able to reach the, you will be able to contact the person, right, from whom you are trying to contact. Okay, so though you are typing a name here, name, and you are dialing with the name, but internally what happening, that name will be converting to a phone number and it is dialing to other persons, right?
yeah,
So in the similar fashion, you are trying to access any website by using the name. Okay, internally it will be transferred, converted to a IP address. Okay, so we can say, a DNS is a kind of a table or the data. It consists of the data regarding the domain name and IP address. Okay, domain name is nothing but the URL what you are trying to access, and its IP address. Okay.
okay,
So it maintains the database for IP address and the host name. Okay. Suppose you are trying to access google.com. For google.com, one IP address will be there. Suppose you are trying to access some internal website. Okay. Some HR portal is there. Okay. So internally it's with IP address only. Na, again. So it is
yeah,
very difficult to remember these IP addresses. Okay. In a similar way your phone numbers. So that's why it's easy to remember the names, right? That's why with the host names, IP address will be assigned. So we can say in a simple way, DNS stands for domain name system, which contains the database of IP address and the host name. Okay,
okay,
so if you are trying to access any website, okay, so let's see, how we'll be able to get the IP address. Suppose you are trying to access google.com, right? How you get the destination IP address? Google.com is the host name, but our computer
mm,
doesn't know about IP address, right? So let's see how you will be able to get it. Okay, this is the computer, and you are trying to access google.com. Okay, so first it checks the local DNS server. So local DNS server in the sense, like inside the organization. Okay, so suppose you are trying to access anything, they'll be having some local DNS server. Okay, first it checks in the local DNS server. Okay, so you are having any IP address of this google.com or what? Okay, so first it will check in this database. If it's not available, okay, so it will contact with root server. So root server is nothing but like if you observe, okay, we are having .com, .online, .edu. So like that many servers are there now, many websites are there. Okay, so here I mean almost we have 13 this root server will be there in the entire world. Okay, so like .com, .online, like that we have 13 root servers are available in the worldwide. Okay, so here what you are trying to access, google.com, right?
build up.
So this our local DNS server, what will happen, it will contact with the root server, that is .com root server. Okay, so this is the second step, it happens. Okay, and what you are trying to access, google, right? So then what it will do, root server will provide, so you are trying to access .com, right? So here what happened, this is the top level domain. Okay, so you are trying to, root server consists of this information, okay, about all 13 root servers. Okay, then what you are trying to access, .com, right? So it will provide the IP address of .com servers. Okay, so here that is
Okay,
called TLD server, top level domain. Okay, so it will send a request again. Okay, so it is the root server where we are having 13 root servers. Okay,
servers.
so among them we are trying to access .com, right? It provides the information about .com server, that is top level domain. Okay, it will come here, it will go, and it will come back here with the root server. Okay, so here it will contact .com server. Okay, this is a .com server. Okay, and then it provides google.com, right? So in this .com we'll be having all the list of websites related to .com. Okay, so here google.com is there, so it will send a response about google.com DNS server. Okay, so here like it will authoritative name server is nothing but it's a Google, right? So who is maintaining the DNS server? Google DNS. Okay, so it will send the information about Google DNS server, and it will contact with Google domain authoritative name server, and it provides the IP address. Okay, and then that IP address will be forwarded to our computer. This is what it happens, like though you try to access any website from your mobile or laptop also.
Okay.
Okay, so we need to have an IP address, right? So if to get the IP address, it needs to get it. So here, if you're trying to access google.com, first it will check the local DNS server. If it's not available, then it will ask the root servers, 13 root servers. Okay, so it is .com root server. Then again it will come to .com, then Google. Okay, then Google DNS server. Okay, in the Google DNS server, it is having the list of information about the IP addresses, and that IP address will be shared to local DNS server, and it is saved here. Okay, this is the process. So next time if you are trying to access that, like DNS entry will be saved in the local DNS server for a while. Okay, so this is about DNS and how DNS is working.
Okay.
So whatever it's not only with respect to public network, even inside network also, like in the organization is there, right? In the organization, suppose I'm organization belongs to ABC organization. Okay, so if you are typing any website regarding ABC organization only inside the office, then everything they will store in the local DNS server. So if you try to access local DNS server will contact, and this local DNS server will having the information about what you are trying to access. So you will get the IP address here itself. Clear?
Okay.
This is what happens. Okay. Next we'll go with one more concept that is called DHCP. Okay. So let's see about DHCP. So like before going further, okay. So if you are trying to access anything, okay, so suppose you are accessing like what is the weather today, so you are requesting some information, right? What is weather today? So that requesting that information is called like a HTTP request. It's not only what is the weather. Okay, suppose you're trying to access google.com only, so it will provide some response, right? Google web page, search engine it will show now. So that sending the request is called HTTP request, and it will go through internet and it will reach the web server. Okay, suppose if you're trying to access google.com only, okay, it will go through internet and it will reach the Google web server, and it will provide you the Google page now.
Yes.
That is called HTTP request and HTTP response. Not only with respect to Google, okay. So if you type any website, okay, suppose you're trying to access some.com, okay. So what happened? You sending a request and you are getting a response. What is the response request that you are sending? Okay, suppose you are trying to access Facebook login. Okay, so you are sending a request to Facebook. So Facebook is providing its response to you, right? So this is the login, URL to login. Some information is providing back to you, right? That is called HTTP response and HTTP request.
Okay.
Okay. Next, we have a concept called DHCP. So if you observe, like as we discussed, in earlier sessions, okay, as soon as your computer connected to Wi-Fi, okay, you will be assigning with some IP address now. So here in the backend days, like what happening, like a IP address will be assigned to each and every computer manually. Okay, manually in the sense they will log into your system and they'll go to like network settings. They will assign some IP address to you manually. Okay, so but like as the technology is growing, like as sometimes we need to no need of this IP address to be constantly assigned to this network. Okay, this host. So it is waste, right? Continuously if you assign. So that's why. And one more reason is if any if n number of people, like connecting to the network, it will be difficult, to assign the IP address manually. Okay, so that's why we have concept coming into the picture, that is DHCP.
Dynamic host.
DHCP stands for Dynamic Host Controlling Protocol. Okay, so what happened, this DHCP server having the capability of assigning the IP addresses to the host connected to the network. Okay, suppose, like you are you have, like mobile or computer. Okay, so you connected to Wi-Fi or you turned on your mobile signal. Okay, so what's happening, as soon as you connected, this Wi-Fi having the capability to assign an IP address. Okay, so that is called, like we can say DHCP, dynamic. So if any number of computers are connected to it, okay, so it is assigning IP addresses to that now. That is called, like a dynamic host controlling protocol. Okay, so here dynamically assigns the IP address to the host connected to the network. That's about DHCP. And okay, and here one more thing, like what you need to remember, how they are assigning the IP addresses. Okay, this is connecting to the network. Okay, how it's getting the IP addresses, that process is called DORA process. Okay, that
Okay.
is called, discover, offer, request, and acknowledgement. Okay, so let's see, like what happens. So this is the 4-step process. Okay, so
Okay.
like yeah, let me tell you how it is. So here, like you are having your mobile. Okay, this is your mobile. Okay, and this is your DHCP server or Wi-Fi. Okay, so this Wi-Fi having some IP information, right, in general. Okay, so here whatever the device which is connecting to the network, it will send a discover message to all the computers which are connected in the network. Okay, it's not only Wi-Fi, whatever the things it is available, it will send a broadcast message. Broadcast is nothing but it sends to all the things, okay, wherever it is connected. So it is sending information saying that I'm not having an IP address, I want some IP address. Okay, so then what happened, a DHCP server will respond to that. Okay, so while sending this message, it should be consist of source IP, destination IP, source MAC, and destination MAC. Now 4 details we require, right? So here source IP address, we don't know, right, what is this IP address, because it's trying to connect the network. Clear?
Okay.
So here
Yes.
there is no source IP address. Okay, that is source IP is 0.0.0.0. Okay, and this network, it doesn't know where is DHCP configured, right?
Yes.
So it will send a broadcast message, that is IP address is 255.255.255.255. Broadcast message, it is broadcast IP address. Okay, and source MAC is nothing but the device what is it trying to
Mobile.
connect. That is mobile MAC address. And destination MAC address, it is not aware, right? IP address of it is not aware. How will get the MAC address of this Wi-Fi device? It doesn't know. So it is the broadcast, it will send. Okay, so while sending a discover message, the IP address of the like the client or mobile is 0.0.0, and the MAC address of source is the specific MAC address. Okay, and the destination, it doesn't know. That's why the IP address of the destination and the MAC address of destination, it is a broadcast one. Okay, this is the first step, it happens. Okay, and second
Okay.
step, what happens? Okay, so your mobile is sending request to Wi-Fi, right? So here what happened, this Wi-Fi, though you have many devices, Wi-Fi having the capability of assigning IP addresses, right? So it will respond to your device saying that, okay, I'm the DHCP server. Okay, I can assign IP address to you. Do you want? Okay, let me explain you first this one. Okay, then it will be clear. So a client is connecting to DHCP server. Okay, this Wi-Fi, consider Wi-Fi it is. Okay, so client will send saying that, hi, will you please give me an IP address to me? It will request, like in general. Okay, so it will discover the DHCP server to get the IP address. Okay, that is called discover process. Okay, and the second thing what happened, like the DHCP server will respond. So here, it doesn't know about what is DHCP server, right? It's into all the many things. Okay, so then what happened, DHCP server will get give the response to the client saying that yeah, I'll give you the IP address, this one to you. Are you okay with it? Are you accept it? It will send the offer message. Okay. Then what happens again? Client will send a request to DHCP server saying that, yeah, I'm okay to accept this IP address. Okay. Then DHCP server saying that, yeah, I'm acknowledging, I'm assigning this IP address to you. Take it. So this is the 4 steps it happens. Okay. First message is
Okay.
discover message. Second one is DHCP server
Offer
is offering some IP address, and the client is requesting saying that,
accepting the
yeah,
request.
I'm accepting this IP address. Okay. And DHCP server, it's confirmation. Okay. These 4 messages it's happening, right? Okay. So that 4 messages, how it's happening. Okay. So discover message, it doesn't know what is IP address, so it is discovering the DHCP server. Okay. And then what DHCP server is doing, it is offering an IP address, right? So while offering the IP address, it needs to share that information to the mobile where you trying to connect now. So while offering the
Yes.
IP address, the source IP address is Wi-Fi source. I mean, like the DHCP source IP address. Destination IP address is, it doesn't know, right? Still, there's no IP address assigned to mobile. Okay.
Yes.
So that's why it will send a broadcast again. Okay.
Mhm.
And MAC address of DHCP server, that is source we are sending, right? And destination MAC address is, it gets the request, right? And in here it got the
Initial.
MAC address of source MAC address, right? So that's why it will
Mhm.
send the offer message to the specific DHCP server, DHCP client only, that is mobile.
Okay.
Okay. That is called like offer message. And then what it is doing, again, it's accepting the IP address, right? While accepting source IP address, mobile is not assigned any IP address, right? Just accepting it. Okay. Once DHCP server confirmed, then only the IP address will be assigned to the mobile. Okay. So again, the source IP is nothing, is not aware, and destination IP address is like what I can say is again, it's a broadcast source MAC and destination MAC, we are aware now, because it got the response from the DHCP server, right? So it stores its
Yes.
like MAC address of the DHCP server. So this is what happens in the request message. Okay. And in the acknowledgement, source IP address is DHCP server IP address only. It is saying that confirmation. Acknowledgement is confirmation of IP address. Okay. And destination IP address is broadcast again. Okay. So this is like the information about source, destination, source MAC and destination MAC. Okay. But in general, this is the 4 steps. What happens? It will discover the DHCP server. Okay. So
Okay.
DHCP client discovers the DHCP server. Okay. Once discoveration happened, then DHCP server offers
Offer
an
of
IP
IP
address,
address.
and DHCP client, what it does, it's
Accepting IP address.
it's accepting the IP address, and DHCP servers is acknowledgement. Okay, I'm confirming that I'm assigning this IP address to you. These are the 4 steps. Okay, but while processing these 4 steps, we need to have source IP, destination IP,
Destination IP,
source MAC,
source
and
MAC,
destination MAC.
destination
Right?
MAC.
So this is what like it happens in the DORA process. There are 4 steps. It's there. No, this is what this is about source IP, destination IP, source MAC, and destination MAC. While processing these 4 steps.
Okay.
Okay, so this is the process. What happens when you connect it to the Wi-Fi network or anything to get the IP address?
Okay.
Okay, clear about
Yes.
DHCP?
Yes.
Okay, so next protocol we have ICMP protocol. Okay, so here ICMP stands for Internet Control Messaging Protocol. Okay,
Okay.
so like this protocol, what it does, it's mainly it checks if destination is reachable or not, ping and trace out. Okay, so destination is reachable or nothing, but like it's ICMP, it's mainly ping. Okay, so if you want to
Okay.
check if any device is alive or not. Okay, so suppose you are sitting on one location. Okay, and in different location you have some server. Okay, so this is user and this is server. Okay, if you want to check if it is if the server is live or not, live is nothing but if the server is on or not. Okay, so what you can do, if you try to ping the server IP address 1.2.3.4, okay, it will get the response to you saying that I'm alive. Okay, it will get some response also. Let me show you how it is that. Okay, that is about ping. Destination not reachable, like this is one of the common event it is, okay. If like this server is not alive, okay, then it will show saying that destination is not reachable, okay.
Okay.
And trace route is nothing but okay, suppose like if you can say this is the organization, okay. So here you are the user and this is some server is there, so it has to go through routers and firewalls, right? Many routers it has to pass through, right? This is in the different network, this is in different network, so these networks are connected by using routers, okay. So it will show the path how we are able to reach the destination, that is called trace route, okay. So let's try some practical examples, okay. Able
Okay.
to see my screen, right? I open command
Yes.
prompt. Command prompt.
No, no, I can't able to see that.
Okay, 1 second. Hope you are able to see now.
Yes.
So I'm just like trying to ping something. Okay, it's a 8.8.8 is the Google DNS IP address. Okay, in general. Okay, so I'm trying to ping. I'm getting reply from the Google DNS server. Okay, within like this is the bytes information. How many bytes? And this is the milliseconds. And TTL is nothing but time to live. Okay, so this is what like it happens. Okay, if you try to access anything.
Okay.
Okay, clear. So if you ping is one of the protocol which is used to check that Google DNS server is live or not. Okay, suppose I am trying to ping something. Okay, let's see 192.168.10 dot something. So here I don't know if the server is live or not at all. Okay, so what you are getting, request
Request time.
timed out. So like this device itself is not there, how it get the response? It won't get, right?
Okay.
That is about ping. Okay, to check the availability and response time of the server, we'll use the ping command. And we have one more command also that is called so here if you can see, okay, how many bytes, how many packets we are sending? 4 packets, right? 4
Yes.
messages now. 1, 2, 3, 4. So here if you can see, sent is 4 bits, 4, and received also 4 packets, right?
Yeah.
So we are getting response. So last is 0. Okay, so we are getting 100% response. Okay, so here if you can see, we send in 3 messages, and but we are not getting response from it, right? That's why received is 0 and last packets are 100% loss is there. Okay, so here 0% loss because we are receiving the destination response. Okay, and suppose like I want to see like how I can reach the Google DNS. What are the servers are like routers are there? If you check by using traceat command in Windows. Okay, if you are using like in case of any Linux machine, trace route it is traceat. In case of Windows, okay, it will show like the maximum is 30 hops. Okay, so it allows only 30 routers in between my source and destination. Okay, so if you can see this is my router gateway. So I connected
Okay.
to Wi-Fi network, right? So this is the IP
Yes.
address of Wi-Fi router. And after Wi-Fi router, it has to go further, right? Let's see how it shows. Okay, so let's wait for some time. It will show that. So I know everything is showing request time, but it will. If you can see here, we are getting the response again, right? See.
Yes.
So like that it goes. Okay. So if you can see, the here this is the IP address of Act Corp. I'm using Act FiberNet. This is the IP address. Okay.
Okay.
So what happened when I'm trying to access Google? First, it is going to my Wi-Fi router, and it is going, like some. If it is doing request timed out, there is some. They have blocked something here. Okay. That's why it is not showing. Okay. Again, it is going to Act FiberNet IP address. Okay. So let's see how it shows. Okay, so it is trying to get some other information. Next hop where it has to get the IP address, right? Still here, like we could see. Hello. So here, if you can see, so it is going to
Yeah.
some other IP address. Okay, so what does it mean? So from source, it is
Yes.
some source to destination. This is the my IP address is source. Okay, so tracer is completed. See here. So what does it mean? So like my IP address is, let me try. My IP address is 192.168 some 0.10. Okay, let me try that. IP config. So my IP address is 192.168 0.106. Okay, so I'm typing google.com from here. So when I'm typing google.com here, first it is going to my Wi-Fi IP address. Okay, then internally it's going and it is reaching the ACT FiberNet public IP address. Okay, so from ACT FiberNet it has to reach the Google DNS server. So these are the 3 routers which are available. Okay, so we can say between me and google.com there is a connectivity. Okay, me in the sense with the ACT FiberNet, what is the network I'm using? Okay, so this is the functionality of tracer. Okay, so it's like it's not only google.com. Okay, inside the organization. Okay, so let me type like a trace at my gateway IP address. Okay, 192.168.0.1 is my gateway, right? So let me type my gateway itself, this next hub itself, right? So next, like it will end up with only one router itself. See here, next IP address, I want to reach this one. Okay, so where it has to go? It has to go through the single IP address only, because this is my destination. Trace is completed. So if you want to check, like the number of hops or devices in between source and destination, we use the tracer command. Okay, in the command prompt. Is it clear?
Yes.
Okay. Hope you are able to see my presentation now.
Yeah. Yes. No.
Okay, one second. Now you are able to see, right?
Yeah. Yes.
So this is about like a ping and traceroute commands.
Okay.
So like like in this class, what we discussed about application layer protocols. That is what is telnet, what is FTP, what is TFTP, and
Okay.
what is SNMP and its components. That is SNMP manager, like
SNMP
SNMP
agent.
agent, and what is management information base, and different versions of SNMP. That is version 1, version 2, and version 3. And then we discussed about like what is DNS. Okay, and like when you are trying to access a website, okay, what's the process it happened on the back end? We discussed about this, right?
Yeah.
And like if you're trying to access anything, that is HTTP request,
Mm.
and what is the response you are getting, that is HTTP response. Okay, and then we discussed about what is DHCP. DHCP stands for Dynamic Host Controlling Protocol. It assigns IP addresses dynamically to the host connected to the network. Okay, and it happened in the four steps. It is, that is discovering the DHCP server. And then what happened? Once discover, like the client will discover the DHCP server, and then DHCP server will offer an IP address to the client. What client will do? Client will accept that IP address, and then DHCP server will acknowledge that IP address. Okay, so this is the four steps it will perform on the DHCP. And then we discussed about ICMP protocol. So ICMP stands for Internet Control Messaging Protocol. Okay, so here ICMP messages are carried out in the IP datagrams using sending error and control messages. Okay, you just go through it once and let me know if any doubts. Okay, so here these are the following functionalities of ICMP, that is ping, trace route, and destination is unreachable if the destination is not alive. Okay, so this is about like application layer protocols. So in next session we'll discuss about like a TCP and other concepts. Okay, that's all from my end for today.
Okay.